I'll go ahead and get started since it's a couple minutes after 11. Again, thanks everyone for calling in today to this Cloud Bank Cloud Clinic. I'm running the show today. My name is Scott Henderson. I'm a research scientist at the University of Washington. I work at the eScience Institute and also in the Department of Earth and Space Sciences. And I've been helping out a group here at UW on the Cloud Bank project, specifically thinking about um, outreach, education, and ways to engage folks outside of computer science that are coming from different domains and getting excited about using the cloud. And that's my own experience with getting interested in the cloud. And one of the things I'm excited to talk about today is utility that I've found very useful for numerous projects. It's a piece of software called SkyPilot, and it's an open source software package that we've been using to simplify and manage cloud infrastructure for various groups here at University of Washington. I'll go ahead and jump in. Uh, just a reminder, this meeting's being recorded. Feel free to take video off or come off mute. At the end, I hope there'll be a bit of discussion. And so I'll just, I think the recording will continue, but we will not post the kind of discussion afterwards. So at the end of this presentation, I'm hoping we can just come off video and have some discussion about what I present today. So Cloud Bank, I assume everyone on this call knows about it because I think that's the main advertisement for these clinics. But it's really exciting, I think, what's happening in recent times with Cloud Bank and being more open to research groups across the US. So really anyone doing research in the US can gain access to a cloud account through Cloud Bank. And that is through the accessci.org website. So this is a unified kind of portal to get access to advanced computing resources, traditionally HPC resources like the Derecho supercomputer at NCAR. But now with Cloud Bank, you can also get access to a cloud account, which opens up, I think, a lot of exciting workflows. So the presentation today is going to focus on not setting up an account. I'm assuming folks have access to one already, and just making use of that account. So what is SkyPilot? In brief, this is taken from the documentation page, which I've linked on these slides. And there'll be a link to these slides at the end of the presentation too, so you can access these links. But in their own words, I'm not a developer of the SkyPilot software. SkyPilot is a system to run, manage, and scale AI workflows on any AI infrastructure. In my opinion, it's really not about AI as much as the landing page of their documentation suggests. And this is maybe a trend just with computation and software in general these days. But it is a workflow management system. It's a way to both set up infrastructure as code, computing infrastructure as code, and also a lightweight workflow management system. So I think this is best illustrated through example, which we'll get into. It's a very active project on GitHub. There's frequent commits by many different contributors. And again, it's open source and not, it's mainly run and got started out of a lab at University of California, Berkeley. And there's a wide range of contributors to this project. So in schematic form, as you see on the slide, what it is it's a layer that sits on top of different computing infrastructure. So you could imagine having cloud VMs or access to servers in your lab or at HPC. It's a way to normalize the access and management of that infrastructure and run jobs on different infrastructure you have access to. So it's sort of divided into three different categories. One, clusters, which is setting up that infrastructure. Two, jobs, which may be, at a basic example, a Python or other script using your favorite programming language, and then services. So you could imagine doing things like setting up API endpoints um, as well through this system. All right, there we go. So one nice thing about this project is they have a pretty extensive design philosophy. This group has published a couple papers about why they're developing this project and what the vision is for this
Hey
project.
Scott,
Yeah.
your slide is not changing. It's
Thanks.
yeah,
Maybe,
maybe you go into presentation mode and then
yeah.
use the navigation thing.
Apologies. Thanks for, is it advancing now? If I toggle?
Yes.
Okay. We'll stick with that. All right. So did you all see this slide?
No.
No? Okay. Thanks for pointing that out. All right. As I was just mentioning, and okay, now I can see the chat. Okay. Yeah, thanks everyone. Bear with me here. Um, SkyPilot sits as a middle layer on top of different compute resources. It's software to simplify deploying resources and then also running computational jobs on those resources. So think scripts, your workflow of choice. And then I was getting into their design philosophy. So this group has published a few white papers and presented abstracts at conferences. These are interesting kind of visions, and the essential idea here is that people are getting access to a lot of different computing resources. And to best take advantage of those, we need kind of a layer that optimizes across those different cloud providers. So you could think of this from different standpoints. You know, an economic argument might be that it's far cheaper to run GPUs in certain data centers compared to others at any given time. And so there's an economic reason to do this. But there's also, I think, a nice kind of reproducibility minded rationale to this, which is as you set up a workflow as a scientific researcher, you want to ensure that you can run that workflow now and into the future. You want to be able to share with collaborators and make sure things run across different providers. So I think there's also an argument to be made for this unified interface, regardless of which cloud you're running on. And the Cloud Bank project, as folks may be aware, provides access to numerous cloud providers. So you could be working on Azure mostly, AWS, Google, on-premise infrastructure. You know, these things change over time, and so having an interface to normalize across those providers is very helpful. Um, this is a bit of a flow chart we put together for cloud in particular. I've found I've experience with several different kind of cloud infrastructure management choices. Often the first thing folks do is jump into the cloud portal, you know, get onto Azure, click some buttons to launch VMs, and maybe take screenshots and document that process. But it's not particularly reproducible to do that. So we want to be using code to sort of encapsulate a reproducible workflow all the way from infrastructure to running software and result. All cloud providers provide their specific software development kit. So this is, you know, typically kind of bash scripts or Python interfaces to do the exact same things you do in the portal, but through code. Um, and that's great, but it's specific to each provider. Then you have different options to sort of normalize that software as infrastructure as code, sorry, through systems like Terraform or Pulumi, if people have heard of these. These allow you to write configurations, again, across different clouds and sort of interface with these APIs that the cloud providers have for that infrastructure. And finally, there's a lot of startups trying to simplify this whole process for people for certain workflows. So for GPU access, we've worked here at UW with Modal a bit, which is focused on fast GPU access. These systems tend to potentially be charging extra. You have to set up accounts with these companies who provide these services, which is worth it for some people, but not worth it for others. So you're paying a premium for extra features. And if you have a cloud bank account, you kind of just want to use that account, I think. And so SkyPilot is an alternative where there's not as much fanciness, customer support, but you can do a lot of the same things as with what these companies are providing. Okay, so I mentioned this a little bit. Why embrace this infrastructure as code approach? One is reproducibility of the full workflow. I think two is that there's this fear of potential vendor lock-in where you get stuck in one cloud, the credits run out, now you have an opportunity to go to a different cloud, or it just builds in this kind of transferability of what you're doing from the beginning, which is nice. And also, you can often, as you'll see with SkyPilot, add in some additional niceties that don't typically come with default configurations when you're running on, let's say, setting up a VM through Azure. You get additional things like auto shutdown of machines, logging of the workflow, and then also a dashboard to see kind of jobs as they run. So what's the setup of this system? You can install SkyPilot just as a Python package. So if you're an individual working from your laptop and want to launch things on the cloud or HPC, you can just create an environment, install SkyPilot, and it will launch a local server and route requests to launch other machines on the cloud provider through that local server. Very easy to do this. And then you log in with your cloud provider credentials and then write definitions of what resources you need in YAML files and then launch configurations through those files. That's all run locally. So it's very easy, but it doesn't allow, say, a collaborator to see what jobs you're running, or for someone else, grad students, other collaborators to launch through that same server. There's, for the multi-user case, another option, which is to run a Kubernetes server. So SkyPilot has a defined server that you can deploy. It essentially runs a very small virtual machine through Kubernetes. So this is running on a cloud. And once you set it up, there's a URL that you go to, and instead of the local URL, you're just pointing at this external one. And that VM is then going to farm out your requests to launch infrastructure. Again, that infrastructure could be anywhere. So the server can be running on Azure, but you can launch machines on AWS. You can launch machines on a local HPC, etc. And this has the benefit of giving visibility to a full team of the different clusters or workflows that are currently running. So it's good for a team, but adds that additional complexity. So a use case, I just want to highlight how we've been using SkyPilot. This is a project that's run here at the institute where I work at, which is just a quarter-long kind of fast-paced accelerator program to give teams access to advanced computing resources or try out new methodologies in their research. This is a project led by Hernan Kerbes, a master's student in the University of Washington Civil Engineering Department, who is a computational hydrologist. And Hernan is working to apply transfer learning to forecast daily reservoir flow throughout Uruguay. So this project uses software neural hydrology that's behind the scenes using PyTorch to train neural networks, and you're inputting a bunch of static attributes for, say, a river basin, also dynamic attributes over time, so the precipitation in different basins, and you have sparse in situ measurements of stream flow at given points. You want to predict that stream flow time series accurately and for many different locations. I always like to highlight the kind of the research use case of why we're setting up all this infrastructure. And so I think this was a nice project because while you may not be familiar with hydrology, this kind of pattern of I have some software that uses PyTorch to train a model. Here's what I want to do. This is quite common with research groups these days. So this use case, I think, starts with interactive GPU access. This group had access to local HPC, but was sometimes had quota, sometimes didn't, was kind of often not having access to the GPU type that they wanted necessarily locally. And so they were drawn to the cloud for the promise of this scalability and also just more consistent access. I've found working with a lot of different academic groups that in general, a lot have bursting compute needs. So I would say many, if not most, have this kind of style of computing where you're doing a lot of exploratory analysis and you scale out at the end. You set up a batch workflow at the very end of your project once you've iterated a lot with Jupyter notebooks and kind of temporary access to machines to scale out to big computation. And this use case of running this model in Uruguay has that same pattern. So our setup was to use SkyPilot to give access to GPUs, interactive access. We access machines through VS Code, SSHing into the machines once we launch them through SkyPilot. And currently, different GPUs we found are easy to access. T4 you can access straight away. Other more modern ones you request through Azure once you get a Cloud Bank account access to those GPUs, which takes a few days, but that tends to be approved pretty quickly. However, this promise of like any GPU anywhere on cloud providers, I think is a bit overblown. We're surprised that you can't access certain GPU types in certain data centers. A lot of caveats around GPUs right now, I think. So what does this configuration look like with SkyPilot? It's a simplified kind of subset of what you most commonly need, which is CPU, RAM, GPU, hard disk space. That defines your cluster. So as you can see in this example here in YAML, I'm saying I want these resources to run this workflow. We really want to run an Azure West US3, so we've specified that. This can be because you have a data set in a particular data center, for example. And I'm requesting a specific GPU type, in this case, just A100. You also specify shutdown preferences for this cluster. So you can, with SkyPilot, either select to automatically shut things down, which means you can relaunch them. For interactive workflows, this is important because you want to be able to shut down the machine when you're not using it on the cloud, but then get back to the same machine so you can save data in the local drive. Or you can set things up to automatically delete completely. So if you have a batch workflow, you can change auto stop to basically terminate the entire infrastructure. You can also sync code between GitHub repositories. So this is the kind of way we encourage moving code around so that the code is always kind of under source control, and you can move it to different machines very easily. Then you have, a way to set up that machine. So here, maybe you're configuring a virtual environment, ensuring that the GPU is working. And finally, you have a run section of this workflow definition, which is where you would run your script. So in the case of kind of the batch workflow, that's where you can run this final script. In the case of an interactive workflow, it doesn't really matter. This machine is going to be on for at least 10 minutes. And once it's active, once the CPU is running, if you log into VS Code, then it still runs until you're inactive and not doing any computations on it. So I've provided a link to our setup for this accelerator project. If people want to look later at different configurations you can do. For data storage, you can request different sizes of ephemeral disks when you launch machines on the cloud. However, workflows currently through SkyPilot are mainly focused on using cloud buckets. There are different ways you can interface with these buckets as object storage. You can point to a bucket and have everything copied when you launch a machine, or you can access files on those buckets in a streaming fashion. There are also options that are coming up with newer versions of SkyPilot to attach networked drives, but currently that's only for running workflows on Kubernetes rather than specific cloud providers. So finally, just once you've kind of experimented with your interactive work, as I mentioned earlier, a very common pattern is to then farm out your computations in a batch computing sense. And this schematic is taken from the SkyPilot documentation, where you launch a job in the same way. You can point to a YAML file defining that job, but say you want to do a parameter sweep of testing all sorts of different training rates or different configurations in your workflow. You do that through specifying environment variables. This allows you to either point to kind of a single file that's a list of all your different parameters, or you can do a loop through different configuration files and then farm out those jobs through SkyPilot to your different infrastructure. So that could be a single cluster. You could just set up one very big machine in one particular data center in Azure, or you could have this happening across clouds. Some quirks, some caveats. There are some unexpected things that we found over the past couple months using this, using SkyPilot, that I figured I'd point out. So one is that certain regions require additional setup. You might get the impression visiting their documentation that they support all these clouds and everything works kind of identically across all clouds. And that's not the case right now. So certain regions require a bit of additional setup. I found this needing to run some workflows in West Europe, where there's a large kind of remote sensing data set stored. And while there are over 20 clouds supported, which is important because of this vision of kind of supporting access to all infrastructure in a unified way, there is, of course, kind of more development happening on specific providers. And that's just because I think as open source software, people are working more often in specific clouds. And so I've found that Kubernetes, AWS, and Google kind of have the best, most up-to-date support. Maybe don't have as many bugs showing up. That said, it's open source. So one of my main points, and one thing I love about using this, is that if something doesn't work, all the code's there. And if you're feeling motivated, you can fix it. You can contribute fixes either to documentation or adding some new feature for Azure if it doesn't exist. And in summary, I think it can be hard to manage cloud infrastructure, especially for groups getting started. There's lots of jargon, lots of settings, and it's very easy to leave things running. So SkyPilot is nice because it simplifies a lot of that common infrastructure needs setup where you need VMs, storage, and kind of automatic shutdown of clusters that you're running on. We've had a really positive experience, I'd say, running it as a server, API server on Kubernetes for small groups so that multiple users can just easily launch VMs with a GPU whenever they need it and start running Jupyter notebooks and testing out workflows with that GPU before moving on to the batch computing. This software supports, as you saw, I think it was 20 plus clouds with mostly the same configuration. And that's the YAML that I showed earlier in this presentation, where we're just saying CPUs equals 4. You don't need to know the names of instance types, all these other things. That is normalized across these providers. But there are some quirks and kind of bugs that may show up for some of the lesser used cloud providers that are supported, but not as actively worked with. That's all I have for this presentation. The slides, there's kind of a short link to these slides, and then the SkyPilot documentation, which you can dig into in more detail, and also the Cloud Bank project. If people want, please kind of come off mute at this point. We can just field questions. I can also show quickly kind of what this looks like through the command line for launching a small kind of job. I'll stick around for the next 10 minutes or so. But if people want to talk longer than that, the Zoom room is open, so we can use it. So thanks again, everyone, for joining.